Okay, so now we have piece, and if we want to see them, well, we need to start creating some pieces. So inside of my board class, under create board, I'm going to create a bunch of pieces. We're going to start obviously by making the white pieces will be at the top, and then the red pieces at the bottom. So this is not too complicated, but it is a little bit of a for loop kind of indentation thing that you'll see here, because we need to obviously have them be spread out. We're only going to have, I believe, 4 in each row, and then they need to be staggering, and then the white needs to go up there. There needs to be a space, and then it needs to be the black or the red, sorry, the white, and then the red, my bad. All right, so 4 row in range rows, 4 call in range calls. We can import calls up here. Technically, again, I mean, I can change this here to be calls. Doesn't matter because they are the same value, but say we had a checkerboard that wasn't exactly square, then these would matter. So 4 row in range rows, 4 call in range calls. What we're gonna do is we're gonna start by saying self dot board dot append an empty list. The reason for this is because we want to have interior lists for each row, right? So we want to have a list that represents what each row is going to have inside of it. And we'll just do that by appending one for each row that we have. Next, what we're going to say is if call mod2 equals a little bit of fancy math here, row plus 1 mod2. What this is saying essentially is if the current column that we are on modulus 2, so if it's divisible by 2, if that equals whatever the row plus 1, so say we're on row 0, technically we're on row 1 mod 2, then what we can actually do is we can draw the red or white cube. Now, if we look at the checkerboard, I'll kind of explain to you how this works by going through a few examples. So when row is, I'm trying to be able to view the code at the same time. So bring it back my Pygame. We've got 2 of them open. Let's close one. Okay, there we go. So let's say row is 0. We're on the first row. Then the row plus 1 mod 2 is going to be equal to 1, right? So that here that I can't highlight unless it will put away this is equal to 1. And then call, so if we're on column 0 in this case, call mod 2 will not be equal to that. So that'll be this first square here, this red one, so we won't draw the checker. I think that's what you call it, like a checker piece, I guess. And then the next cube over, right? So the row stays the same, but the column now is column 1 mod 2. So that's equal to it, so we draw white. All right, move next. Now it's column 2, so we're not drawing that. Next, we go column 3, we will be drawing that, so on and so forth. Now you increment the row. When you increment the row, what happens is row plus 1, so 1 plus 1 is 2, mod 2 is equal to 0, which means we'll only draw on the even columns, right? And then the next one will draw on the odd columns. So that's kind of how this is going to work. And that's like the basis behind this math that I'm explaining. Okay. So in this case, we can draw. So if this happens, we can draw something, but we only want to draw when we're in a certain row. So we have to say if row is less than 3, because 0, 1, 2 are the first 3 rows that we want to draw the white pieces in, then what we will do is we'll say, and we're not actually drawing here, we're just creating the pieces, but same premise. We'll say self.board row.append, and we'll create a piece. And what will we do here? We'll say row, column, and then the color we're gonna put here is gonna be white. So I think I imported white, I did not. So first of all, let's import calls properly, and now let's import white. Okay, so black, row, red, square size, calls white, great, and then we can append white in there. Elif row is, I guess we'll say less than, should be 5, 6, 7 is where, so if we say if row is less than 4, then we'll simply continue. Actually, let's just do this. If row is greater than 4, so if row is 5, 6, or 7, then we can say self.board row.append piece row call red. So hopefully this makes sense, and we need to import piece, which we'll do in a second. But the idea being that we're just creating this board. We're going to do it with the checkerboard pattern, and then obviously we're not going to do anything in the rows that are 3 or 4. What am I saying? 3 or 4. Yeah, in rows 3 or 4, we are not going to add any pieces. Now, when we don't add a piece though, what I want to do is I actually want to add a 0 instead. So I'm going to say else, and in this case, we're going to say self.board row.append 0. The reason for this is that's just going to be like our blank piece. Like we'll have 0 white, 0 white, 0 white, so we can keep track of by looking at the board what row and column each piece is in by having these kind of blank separators. Next, we're going to say else self.board row.append 0. So essentially, if we don't add a piece, we are going to add a 0 so that we can separate the pieces and be able to look at this list and figure out where the pieces are. Now we need to import piece. So we'll say from dot piece import piece like that. Okay, so that should be good. That should create the board for us. Now what I want to do, just to make sure this is working, is actually draw the board. So I'm going to make a new method here called draw. And what this is going to do is say self win, and this will draw all of the pieces and the squares. So this is going to say self.draw squares. So we'll draw the squares on the window, and then we'll loop through all the pieces and draw those. So let's say for row in, range, if we can do this here, for row in range, all capital rows, and then we'll say for call in range, all capital calls. What we'll do is loop through the board. So we'll say piece equals self.board row column like that. And we'll say if piece does not equal 0, because if the piece is 0, obviously we're not going to draw anything, right? So if the piece does not equal 0, then piece dot draw on the window. So I think that should be good. Let's test this. So I'm going to go to main now, and rather than board.draw squares, I'm just going to call board.draw. And let's just make a quick test here and see if we crash. Invalid syntax. Where is the invalid syntax? Okay, so I don't know what error I was having, but I managed to fix it. I think it was because I was actually in the Python console accidentally. But anyways, when I'm running this, I'm getting an error now that says list index out of range. Now, the reason for that is that we have this create board method, but we haven't called it. So I haven't actually created a board. So we have this draw that's trying to loop through all these rows and columns, yet they don't exist in the board. So let's actually fix that by saying self.createBoard inside of our init, so that right when this object gets created, we automatically create the board. Let's try this now. And Pygame is not defined. Okay, so I guess I didn't import Pygame inside of some place here. That would be inside of piece. So let's say import Pygame like that inside of our piece module, file, whatever you want to call it. Okay, now we can run it, and there we go. We can see our red and white pieces, and they look to be working fine. Now, I'm not a fan of how big these are, so I'm going to make them a little bit smaller. We can do that really easily by just changing our padding, right? So if I change the padding to 15 and run this file, now we can see they move down a little bit, and you guys can experiment with those, make those bigger, smaller, whatever you like. Okay, so I think that is good for right now. Next, what we're going to do is we are going to actually work, I guess, on a bit of the logic of the game. So we have now the ability to draw these things. We can see everything. Now we need to actually move them, figure out the valid moves for each piece, as well as we need to figure out what happens if one of these pieces is a king. So first thing I'm going to do actually is start working on how we can draw the crown for a king piece. We'll test that out, and then we'll get into the logic. So to make a king, first what we're going to need to do is we're actually going to need to download an asset for a little crown that we will draw on our piece if it is a king piece. So let me see if I can bring this up for you. I have an image of it. I'm going to pop it over here. You can see this is what the crown looks like. It's a transparent background. So go to the link in the description. It will say like download asset here or something. You're going to download a compressed zip folder. What you need to do is right click on that compressed zip folder, press uncompress or unzip here. So just make it so that you don't have that like zipped up folder anymore. It's an unzipped folder. And then take that unzipped folder, it should be called assets, and just put it inside of this directory right here. So inside of this checkers directory. So it's going to go inside of the checkers directory. not like inside of the root directory. Although you could put it inside the root directory, but we're just going to put it inside of this checkers directory. So let me actually do that. I need to grab that folder. So I'm just going to look for it on my system. So I have assets right here. I'm going to copy that and I'll put that into my checkers folder like that. So now we have the assets, and is this inside of the right one? Yes, it is. Now we should be able to load it. So what I'm going to do is inside of constants.py, I'm actually going to load that image. So I'm simply going to say crown equals pygame.image.load, and I'm going to load assets slash crown dot, and in this case, I think it is PNG. Okay, so we'll go crown.png. Now what I need to do actually is I need to resize this. So it's actually too big by default. We need to make it small enough that it will fit on the actual checkers pieces. So to do that, we're just going to use a method from Pygame. I just have to find it because I forget exactly what it is. We're going to say pygame.transform, I think. Is it pygame.transform or pygame.image? No, I think it's pygame.transform.scale. And what we do is we put the image first, and then we put the resolution that we want to scale it to. So I've just kind of hard coded these numbers in. You could do this mathematically, I guess, but I'm going to go with 45 and 25. This relatively keeps the aspect ratio of this image, and it makes it small enough that we can actually put it on the direct center of all of our pieces, and we can tell them, hey, you know, this is a king piece. So I'm going to make this, sorry, capital again. Don't know why I made that lowercase. And now let's go to piece, and from constants, import red, white, square size, gray, and crown. Inside of the draw, we're going to add a really basic if the piece is king. So if self.king, then what we will do is we'll say win.blit the crown. Blit simply means put some image onto the screen or put some surface onto the screen. That's what it's saying. These are just special Pygame methods to draw directly onto the display, whereas this one, we're just blitting the image. And then we need to pick our XY position that we want to put this on. Now I want this to be perfectly centered, so I'm going to use a little bit of math here to do this. What we're going to say is self.x minus crown.get_width. Get_width is going to get the width of the image. Now we already know what the width of the image is, but what I'm trying to say here is that, let me actually just go to a kind of drawing whiteboard so I can show you what I mean. If we have a square, okay, got it. Come on, let me draw. Why can't I draw? Okay, so apparently Windows or Microsoft Ink just doesn't work, so I can't draw the thing for you right now. I don't know the solution to that. What I'm trying to say is imagine that the X and Y position, or you don't have to imagine, the X and Y position we have is in the middle of the square. So let me just load the other game, and at least I can maybe show this to you. So the XY position is right in the middle, so where my mouse is. Now we want to draw the crown right in the middle, so it's perfectly centered. But if I just draw at the XY, it's going to move the crown, and it'll be kind of to the right, because the XY is the top left of an image when we're drawing it, other than a circle, right, where we have the radius. So I can't just draw it at the XY. I need to draw it someplace to the left and up a bit such that it will be perfectly equal distance from this left side and the right side of the circle. So all I have to do is get the width of the image and subtract half of that to figure out where the starting X position should be. Because that will say, okay, from this point, if this is the center, we just move half of the image's width to the left, and that will mean that it's being drawn perfectly center in the cube or on the circle. Same thing with the Y position, we can do that as well to make sure it happens perfectly in the center. So that's what we'll do. We'll say self.x minus crown.get_width integer division 2, just so we don't have any rounding errors. And then we'll say self.y minus crown.get_height over 2. Great. So that should draw the crown for us in the middle. So what I'll do is just set all of these crowns to be true, just so that we can make sure that this is working and test it out. Pygame.transform has no attribute scale. Well, it would help if I spelt scale correctly. So scale, there we go. All right, let's check this now. Cannot load assets/crown.png. Okay, so let's try to fix this. I believe the issue we're having is something to do with kind of the path system in Python. So what I'm going to do is just take this folder and put it outside. So put it in the main root directory rather than inside of the checkers directory. And now it should probably load. So let's try this now. And there we go. That is working. Just to reemphasize what was happening there. This, I had asset/crown.png. I had that folder inside of this checkers folder. I specifically told you to put it there, but I was wrong. So what we need to do is take it out and just put it alongside the checkers directory. So it's in that root directory, because when we run this main.py file that's not inside of the checkers folder, the path that Python will look at to load images will be in this directory where we loaded main.py. So I would have to say checkers/assets/ if I wanted to load the image the way that we were doing it before without moving this folder. Anyways, not a huge deal, but hopefully that's loading for us. And I think that this is working fine. We can see the crown on all of the pieces, again, perfectly in the center. All right, so let's go back and remove that now. So piece, we no longer want to draw the crown. So we will say false. And now I got to figure out what we are going to do next. So I'm thinking probably what we should do next is actually set up a way to move pieces around and delete pieces. So from board, what I'm going to do is I'm going to make a move method. So I'm going to say define move. I'm going to say self, and I'm going to say piece. So you tell me the piece you want to move and what row and column you want to move it to. Now, what we'll have to do to move the piece is we'll have to delete the piece from where it is, and we'll have to change its position. So that reminds me that we actually need to go to piece and we need to add a move method as well. So define move like this, self row call. So what will happen when we move a piece? Well, we're going to have to say self.row equals the new row, right? Because this needs to say updated. Self.call equals the new call, and then self.calc position. So remember, calc position, which is right here, simply tells us what the XY position of our piece should be. So we have to recalculate that when we change our row and column. So we have move now on piece. So board, what we'll need to do is we'll actually need to, first of all, move the piece within the list, right? Because we have this list that represents all our pieces. And then we'll have to also actually change the piece itself. So piece.move to wherever it's going to go to update on the pieces side. All right, so what we'll do is we will say self.board, and we're going to say piece.row, piece.call, comma, self.board, row, call, equals, and then we're going to say self.board, and we're literally going to copy these just in reverse. So I'll talk about how this works, but this is an easy way to swap things in Python, or swap positions in a list. So what I'm saying with this line here, and I'll zoom out so you guys can read it, is essentially that the piece that's in the position, piece.row, piece.call, so the one we want to move, and I need to spell piece correctly, and then the piece that's in the position that we want to move to, we're going to swap their values by simply reversing it like this. So this piece here will move to this one here, so row call, and then the other one will move to this one. So they'll essentially swap. That's just how this works. And this means we don't need to make like a temp variable, delete something, re-add it in, all that we would usually have to do. All right, so now that we have that, what we'll actually do is we'll say self dot, actually we don't need self, we'll just say piece dot move row column. There we go. So if, or not if, but when we move this actual piece, we'll just move it row column. Now I just want to look and make sure I've done this correctly. I think we have, but there might be some other things that we want to consider here. All right, so now we've moved the piece. This should actually work. We'll test this out after. But what we need to do is make sure that we haven't moved. Well, we don't need to check that. We need to make sure if we've moved into a position where we'll become a king, we become a king, right? So if we move and we hit the last row or the first row, then whatever our piece is should become a king. So what we can simply do is just check if the row column that we moved to is actually a position that should make us a king. And if it is, then we will make that piece a king. And we will also update the variables we have here for the amount of kings that we have. So what I'm going to say is if piece.row, or I guess we could actually just say row, if row equals rows or row equals 0, what we can do is we can say piece dot make king. So this will make that piece a king, and then we'll need to update the red or black. Is it red or white kings? So the reason this works is because if we move into a position that is 0 or 7 for the row, that means that we are at the end or the beginning of the board. Now, some of you might be asking, well, won't this break because we already have pieces in those positions that are the same color, right? So like the white piece is already in row 0 and the red pieces are already in row 7 or row 8, whatever you want to call it. So won't those just become kings? Well, no, they won't, because they have to move into that position. So we're not going to let them move backwards unless they're a king, which means that they won't become a king unless they actually move to the other side of the board from where they start at. Now, there will be a situation where a king will move into not its own side and become a king again, but that's fine. If it's already a king, there's no difference in making it a king again, right? It's not double kinging or anything like that. All right, so if row equals rows or row equals 0, piece.make king, we need to update the red and white king. So if piece.color equals white, then self.white kings plus equals 1, else, so if it's not white, it must be red, self.red kings plus equals 1. Okay, so that should be it for move. What we can do now is check to make sure this is working. So what we will do is just simply put inside of this, actually, we'll just do it right here. Say board.move. And now we run to our first problem. We need a piece, right? We actually need to pass a piece object like this to this move function or move method so that it can move it. So how am I actually going to get a piece? Well, we'll write a method here that says define get underscore piece, and we'll say self row call. So essentially, you give this board object a row and a column, and it will give you a piece back. So this will simply return self.board row call. All right, so now let's just say piece equals board.get piece. And let's pass a row and column we know there's going to be a piece in. So in this case, I believe there's one in 0, 1, because I don't think it starts in the top left corner. So we'll get a piece at 0, 1, and then we'll say board.move that piece right here. And let's move this to, I don't know, where do we want to move this? Somewhere where there's not already a piece. Let's go row 4, column 3. All right, so that should move it into the center of the board, or relatively into the center of board. And what is it saying? Oh, missing one required positional argument column. So oops, I shouldn't have put these in a tuple. I should just have them separated out like this. So 4, 3. Let's run this now. And what is the other one? Piece is not defined. Well, it would help if I spelt piece correctly. Where is it telling me this is undefined? It is undefined here. Looks like, yeah, piece is spelled wrong. Okay, so let's go back to board. Let's go to move and let's fix that. There we go. Okay, run, work. And there we go. We can see that now that piece here is moved over here. So this move method does work. Now we want to figure out a way that we can do it using our mouse, right? So this will be a bit more complicated, but very doable. And the next part of this series here, or this video. So what I'm going to do is I'm going to make a method that says define get row underscore call from mouse. So this will simply take the position of our mouse, and it will tell us based on the position of our mouse what row and column we're in. So we're going to say xy equals position, because this is going to be a tuple that will have the x position of our mouse and the y position of our mouse. And then based on the square size, we can calculate really easily what row and column we're in. So we can simply say, well, we'll make it a bit easier. We'll say row equals y integer divided by square size. So this is really easy, right? And we need to import square size. But if the square size is 100 and we're trying to figure out what row we're in, if our y is at 650, then we know we must be in row 6, right? And if our y is 700, we must be in row 7, right? It's pretty straightforward. So that is how this works. That's how we get the row and the column, just a little bit of division. So we say col xx, or divided by square size. Now we'll need to import square size like that, and we can return the row column. Great. So get row column from mouse position. Now what we'll do is when we press the mouse down, we will get what row and column we're in. We will select that piece, and then we will move that piece to wherever we want to move. So we'll be able to select the piece, and then we can select where we want to move it to. So if pygame.mouse button down, then we will say row col equals, and first we'll say position equals pygame.mouse .get underscore pause. This will get the mouse position. Say row col equals get row col from mouse position. Then we can get the piece associated with this. So we can say piece equals, and we can say board dot get piece row column, and we can move it. Now, what I'll do right now is, just because I don't want to code everything, is I will simply just move whatever piece we select to the same position. So we'll just move it to 4, 3, just so you can see that this does work when we press on the piece. But we will obviously make it so that you're moving it where you want to move it afterwards. Okay, so let's just test this out and make sure this works. So if I select this piece, you can see that all these pieces, obviously they're going to be hidden by that white piece because that's there, but they get moved to that position. So when I press them, they move there. Again, obviously all of them are moving to the same one, so you can't really see, but that is how this works.